Hello guys, in this video we will discussing about Armstrong numbers. As you know, in Armstrong numbers we have to separate the integers. That's why we will have to use while loop here. For using while loop we have to put that numbers into temp variable. So let's do the code. Temp is equals to n while that temp must be greater than 0. R is equals to 10% 10. Arm is equals to arm plus r, uh, and that 10 is equals to 10 by 10. 10 by 10. If arm is equals to the inserted number, then we will print Armstrong. If not, then we will print not Armstrong. So let's run this code. So we have to initialize arm from 0. So we will initialize this upon the while loop. We have to declare here arm. As we enter its Armstrong number, as 153 is Armstrong number. If we put another number, it is not Armstrong number. So this is a basic code for Armstrong number. Let's make the list of Armstrong numbers. For that we will have to initialize this loop. So we have to use for loop here. For I starting from 1 to I less than or equal to n I plus plus The for loop will be run from this to the next of while loop as stored I in temp. If arm is equals to I, then comment this else part. If arm is equals to I, then printf. %d comma that I. Let's run this code. We did some mistake, I think. By mistakenly, we have given the bracket here. So remove this bracket from here and place it to here. Let's run this code. As you can see, it's perfectly running. Let's move on to second number, which is palindrome number. A number which is same from forward and backward. Let's check the given number from user, that is palindrome or not. So we know that palindrome number, we have to break this number. So store this in temp variable. Temp is equal to that number. As this number is breaking, we have to use while loop. While that temp must be greater than 0. R is equals to temp %10 s is equals to R plus s into 10. This is a code for palindrome, and temp is equals to temp by 10. If the number from the user is equals to that s is equals to that number, then printf that number. Then printf it is palindrome. Else printf not palindrome. Before running the code, this is the code for palindrome. It must be initialized from 0. So start this from 0. S is equals to 0 and declare in int. Let's run this code. It is palindrome because 1 to 1 is palindrome. Let's check another. 1, 2, 3. It is not palindrome. So make a list of palindrome number. For that we will have to use for loop. For I starting from 1 to I less than or equal to n I plus plus. The loop will be from this and up to if loop. We have to comment else loop. Store value of I in temp if s is equals to I, then printf that I. Let's run. As you can see, it is printing number which are palindrome. So let's move on to the another type of number, which is perfect number. Let's move on to perfect number, a number whose sum and multiplication is same. For example, 6. So we have to divide 6 to number from 1 to less than or that of number. For example, if we take 6 as a number, so we will have to divide 6 by 1, 2, 3, 4 and 5. In that 1, 2, 3 whose sum is 6 and multiplication is 6, we will not take the limit up to the number because there will be divisible by 1, 2, 3 and 6 the, whose sum will not be 6. So we have to take the limit from 1 to less than that of number. If we take 7, then we have to take limit up to 6. So let's run this code. Let's solve this code. We use for loop for limit. Starting from 1, I is less than or equal to n minus 1 I plus plus. If n% of that I is equals to 0, then sum equals to sum plus that integer. If that sum is equals to that given the input number, then print perfect number. Perfect. Else printf not perfect. Let's run this code. 6 is a perfect number. Let's input 7. It is not perfect number. A question might come into your mind that why we didn't use this if loop here. We didn't use this if loop here because here sum is equals to 12. There is no term of y. So we will not write this term inside the for loop of y. We will write because it is independent of y. We will write this away from that for loop which has I. So let's take the range of that number. So for that we will use a for loop. For loop where I starting from 1 to I is less than or equal to n I plus plus. Let's uncomment this. This upper for loop for taking n will be complete throughout the loop for I starting from 1 rather than n I plus plus. So take j variable here. Here we have to sum is equals to sum plus j. As previous, here was I and here was n and here was I. So we use sum plus I. So because in terms of y this is j, so we have to sum plus j. And here if sum is equals to that number which is entered from the user, it would be equal, then printf that I. Let's run this code. Here it is printing. So these are the range of perfect numbers. Let's move on to prime number. Prime number which is not divisible by all number, means which is divisible one and itself. For example, 5 whose divisibles are 1 and 5, means if we divide 5 up to 1, 2, 3, 4, 5, we will get only 2 numbers. So if we count that number, if the number count is 2, then it would be prime number. As we know, the prime number, we are not breaking that number, so it don't need while loop and temp variable. So we use for loop for the for initialization, for counting purpose, for division of that 5. n percent I is equals to 0, then count plus plus. Here we have to mention count is equals to 0. If count is equals to 2, then print prime number. Else not prime. Let's run this code. It's a prime number. 5 is a prime number. Let's insert 8. It's not a prime number. Let's make the list of prime number. So we have to introduce another for loop. For loop for I traveling from 1 to I less than or equal to n I plus plus. This loop will be entire to the code. Let's comment else. Let's make this j. J is less than or equal to n j plus plus. Here one question might come to your mind that in previous question we have changed this to I, and in this question remains the same, and this is the reason, because in the previous we will not allowing that number up to n, because we will take 1 2 3 4 5 4 6, but here we will have to take the number completely. If we choose 5, then we have to take the number up to 5. So this is the reason behind it. Change n to I, this I to j. Print I, print that number which is given from the user, and the number is n, where n is I from I. Let's run this code. It is showing error because in the list pattern we have to make the count initialize from 0 below the for loop. So write count is equal to 0 below the main for loop. Let's run this code. It is perfectly running. Let's move to the next, that is reverse a number. Here we just have to check the number is reverse. We just make the number reverse. So we we have to reverse the number. That's why we have to break the number. For example, if we take 1 2 3, then we have to make it 3 to 1. That's why we have to break this number. So use while loop and store this number into temp. Temp is equals to that n, while that temp must be greater than 0 if r is equals to that temp percent temp and let's print here that number, or let's p is equal to that r and temp is equals to temp by 10. Let's print that temp. Let's print that r, or simply print here printf percent d of r. Let's run this code. Enter number. As you can see, it is perfectly running. For leap year, the condition of leap year, it must be divisible by 404 and not divisible by 100. Let's write a code to check the year is leap year or not. Let's make here y. If y so is equals to 0, y percent char is equals to 0, y percent so not is equals to 0, then printf here is leap, here is leap year, else not leap year. Let's run this code. Sorry, we have to use here ampersand. This is not a leap year. Let's put another year. It is a leap year. So make a list of leap years. We have to use here for loop. For I, transferring from 1 to I less than or equal to y I plus plus. Comment else part. Percent d of that y. Let's run. Oh, here we have to change I. Replace y by I. Let's run this code. Here, here are the list of leap year from 1 to 888, 8888. Let's start perfect square numbers. Numbers whose roots are perfect number, whose roots are in integer form, means 4, whose root is 2, 9, whose root is 3. So check whether the given number is perfect square or not. So we will take the value from user. For I starting from 1, I is less than or equal to that n. I plus plus. Let's say p. We have to use here sqrt operation. It would be maths.h. Let's say here p is equals to sqrt on that n, that n. is equals to n. Then printf perfect number, else not perfect. It is perfect number. 4 is perfect number. 6 is not a perfect number. So make a list of perfect numbers. So we have to use here for loop. For I starting from 1, I is less than or equal to n, I plus plus. Let's remove else part. Printf if p is equals to a squarity of, let's replace I n with I, %d of that I. Run this code. As you can see, it is earning perfect numbers up to 100. So thank you.